comic book from the 1960s. Is this working? Yeah, okay. And it was something that the daily newspaper said about Spider-Man. So the question was, is Spider-Man a threat or is he a menace? Which was meant to be a rhetorical question. Firewalls are terrible, and I'd rather not have them. The only thing worse is not having them. But before I get to that, I want to rip something else from the headlines more recently. You may know that I wrote a version of the cron program some decades ago, and it was originally written for the BSD team because they were trying to excise all of the AT&T source code so that they could release a completely unencumbered version of BSD. So this would have been late 80s, early 90s. And I thought this would be fun, and it was, and I learned a lot, and it was good. But eventually, Linux came along and became far more prevalent than BSD. And I understand Linux now has something called systemd, which incorporates the functions of cron, and so cron is starting its long-delayed death, which is probably good. But anyway, I still get bug reports. I got a bug report recently from somebody, very polite. They don't know, how old I am or, how to address me exactly. So, Mr. Vixie, I'm afraid I may have found a bug. And basically what they did is they used the cron tab command, which is used to either list or replace or edit your per user cron table. But they put a space. They wanted to say cron tab -L to list their cron tab. And they put a space. They said cron tab -space L. And they were just mystified because this caused their cron tab to be deleted. And they wanted to know, was this something that I had intended, and it doesn't see it in the man page. So I was thinking about this, and I want to show you the answer I did not give him. So I want to say that I am privileged to be the CEO of my startup, which means that my boss is a board of directors, and their boss collectively is the shareholders. But I also feel quite beholden to my customers and to my employees and their families, because without all three of those sets of people, shareholders, customers, employees, I got nothing. And so I fully understand why Intel would answer this question in this way. And it's because they're publicly traded companies, and they work with lawyers. And the lawyers tell them what they must do or what they must not do. And I am tiny, and I also work with lawyers, and I tell them what they must do and what they must not do. So I don't necessarily blame Intel for giving a lawyer-friendly answer, but I do want to say that what I told this guy about cron is, what you actually said was cron tab dash, and it interprets that as wanting to copy your new cron table from standard input. You didn't give it any standard input, so it copied nothing into your system cron tab, and that's what happened here. And then I realized that I was in exactly the position Intel is in with this the Spectre meltdown thing, which is the program is doing everything that it's documented to do, but it's also doing something deleterious that it is not documented to do, which is to say that L that comes after the space is extraneous input. The syntax of the command line does not actually document any options there. So I could have caught this for the guy. I mean, if he types cron tab dash and hits return, he's on his own. But if he types cron tab dash space and then something else, I should be able to say, you gave me something I wasn't expecting. I'm going to choose to do nothing because I'm not sure that you know what you just asked me to do. And that's what Intel should, that's what their chip should do. This whole side channel thing, yeah, they're talking about, there's no bug in the macro architecture. The instructions we told you would have certain effects, have those effects. But the microarchitecture has some side effects that we didn't document, but everybody has them, so it's not our fault. I hate this kind of stuff. And I will publish a patch to cron to fix this, but of course most copies of cron are inside Linux things that have seriously diverged from the main line, so watch yourselves using cron is the moral of that story. But also watch yourself when you buy chips. A lot of us did not know that there was a copy of Minix inside of every Pentium CPU to run that little system administration engine that we talked to for updating BIOSes and whatnot, and that thing hasn't been patched since God knows when. And the Southbridge chip is able to lurk on the port path to your Ethernet controller and use it without your permission and see what you're doing without you knowing it. So I didn't ask for any of that. And I am going to be checking much more carefully about these complex designs that we use in our work, because I don't think these people know what they're doing. Okay. Yes. You know, you ask a good question. I have learned everything I've ever learned the hardest way it could be learned, so that and I learned it over and over again until I learned it often enough and hard enough that it stuck. So chances are I could write a C program now that would not have an off-by-one error in it. But if you're looking at my code from the 1980s, that's something you should really worry about. So yes, I last gave this talk in Estonia in May of last year. So this is kind of a repeat showing, but I offered your program committee a selection, and they picked this. And it's still quite topical. So let's talk about firewalls. The internet, as well as any other reasonable networking standard, lets you exchange a whole lot of arbitrary data that is not necessarily known by the designers of the internet. They didn't consider voice over IP. They just said, we'll give you general enough functionality that you could build stuff. And then eventually somebody said, hey, telephony. But not all the traffic that it is capable of carrying is in our best interests. And I'm referring both to outbound and inbound traffic. Right? I remember when firewalls first came to the fore, I worked at Digital Equipment Corporation, which was the second largest computer company in the world at that time. The first was IBM, and so a lot of times we would compare ourselves to them. You know, what are the trend lines? What are the approaches? We had a firewall that pretty well kept information from getting out. That's right. So we had a lot of protection against our intellectual property leaving the company. And IBM was the other way around. They had a lot of protections against intellectual property entering the company. And that simply was because we were concerned that people would copy our work and that we might not be able to compete if everybody knew everything we had. IBM had as many lawyers as engineers even then. They knew they could protect their work if it was copied inappropriately. What they didn't want to do is have to defend against an attack where somebody else's intellectual property had come inside the company. So it's a totally different approach, but it all refers to the fact that for some value of local policy, not all traffic is good for you, the network operator or the network user, and so that's where firewalls came from. We just block the part that we're not sure about or that we are sure is bad. And this has been the norm since really Cheswick and Belivan wrote the firewalls book in the late 80s. There were a whole bunch of people doing packet filtering is what we called it, but it really got traction and got some names and, you know, became a market trend with the first publication, the first edition of that firewalls book. And what I want to say about these packets is that we hardly ever have a rule that's designed to allow or disallow a single packet. Because a single packet almost never conveys useful information or does anything either harmful or harmless or useful. You need a flow. You need a whole bunch of packets that can be grouped together, and you would look at their 5-tuple, which is to say the IP address of the sender, of the receiver, the port number of the sender and of the receiver, and you would say that all the packets that are going between those two endpoints were part of a flow, and you would describe in your firewall rule a thing that said flows that look like this are allowed. And that's good in a sense, except that it turns out you can tear flows apart in interesting ways. Again, probably side channel attacks in a way if you ask the IP architects about this. And of course the sad thing about working with flows is that if you wanted to create another protocol that was not TCP and was not UDP, and there are some examples of other protocols that have been developed that are far superior to TCP and UDP for certain use cases, you can't do it because everybody everywhere has got a firewall that allows things it understands, like TCP and UDP, and thus anything you tried to enter the market with today that isn't one of those things, you won't find customers, or you'll find a few, but they won't be able to talk to anybody and you will fail in the market. So this is a clamp, not just a glass ceiling, but a blood pressure clamp on innovation itself. We are stuck with what we have, and whatever was on the test network at some network lab at some gateway producer 20 years ago is the only thing that your home DSL is going to allow in or out of your house. So I kind of hate that, but I don't know what we could have done to prevent it. Anyway, I mentioned that flows are not as cleanly delineated as we'd like them to be. And I'll give you an example. If you have an IP datagram, which could contain either a UDP datagram or a TCP segment, and if that IP datagram is too big for some link, if it has a maximum transmission unit size that is smaller than the size of the datagram you're sending, it will split your datagram into pieces and send those pieces. And this happens in the middle of the network, which a lot of us thought was kind of crazy, and IP version 6 doesn't do it, which creates other problems. I'm not going to talk about that. I just want to say that your original datagram becomes several datagrams, and then there are various little header fields that say which part of the original datagram this one is. And so we distinguish between the non-initial fragment, in other words, everything after the first one, versus the initial fragment. So if you have something that is flow-based, firewall that is flow-based in terms of what it's going to allow, like web is okay, the web port numbers are okay, or DNS or something like that, it is only going to see the port number it needs in the initial fragment because the UDP header or the TCP header is there. It doesn't even have to all be in the initial fragment. You can have a fragment that starts in the middle of the protocol header, although that will generally not work. Anyway, so what this means is a lot of us have firewalls that are set up to say, all right, UDP is okay, DNS port 53 is okay, and any fragment is okay. In other words, I don't want to do the work of trying to keep track of which initial fragments I have let through so that I can only allow the non-initial fragments that went with the original datagram. That's just felt like madness. Now everybody does it, but originally it was seen as a bridge too far. And this goes on, right? If you have a rule that says that a SYN packet, in other words, the first packet of a TCP session, the thing that tries to get the session open, is controlled, but all non-SYN packets are just to be allowed through. And again, that's to keep the firewall from trying to remember which TCP flows it's letting through, and just say, I'm going to control the first one, and if the first one doesn't get through, then the non-first ones won't be useful, and so life is good. The trouble is, if you wanted to DDoS somebody, you could send an awful lot of non-initial fragments or non-SYN TCP, and you would be able to hit inside their so-called hardened perimeter simply by sending packets that were outside of flows, but that they weren't doing the work to note weren't part of flows. So this is the kind of weakness that you get that proves to you that none of this was well considered in the days, let's say the 1970s when this was being designed, right? It's a miracle that it works at all, and then it becomes an even more astounding miracle as you start to study the ways it's been abused. Finally, you have this idea of UDP state, where, for example, you might want to say, I should be able to make DNS queries of servers outside my network, and the answers should be allowed through. And so the simple way to do that is to say, if the destination port is 53 or the source port is 53, then allow it through, and that's what a lot of us do. Which is why a lot of us are subject to DDoSes inside of our firewall because somebody just pretends to send us a lot of responses to questions we never asked, and our firewall isn't keeping track of which ones we asked, and so it all just gets through. So I hate this kind of stuff, although I recognize that it keeps me in business and I'd be driving a tow truck if this problem didn't exist. So, because of all of that, firewalls have become stateful. In other words, they keep track of which flows are in process. So you can actually have a rule in most modern firewalls that says let a DNS query go out and let the response to that query come back. And it really is just that one response. Once the response comes through, the state is collapsed and you're back to the ground state without that rule. So these are temporary little rules that go in. But state has mass. These are not free. Just because they're made of ones and zeros and we don't normally think of ourselves as paying for ones and zeros doesn't mean we have the ability to have an infinite number of them ever. No matter how many terabytes you have, there are still terabytes you don't have. So if you fill up the state table with junk, then the firewall will slow to a crawl, either because it doesn't have room for all the state and it has to discard state and then go back to some secondary mode where it's letting things through it shouldn't, or it is not good at having a million flows. It was only tested with 1,000, and with 1,000,000 of them, it's doing some linked list search that's quadratic in terrible ways. One way or another, too much state is bad for you. Now, there's just no way to avoid that. That's in the physics. So if you take everything I just said and apply it specifically to the DNS protocol and think about truncation, then what you need to know about DNS is that UDP is the primary transport. You start any given transaction on UDP, and if it fails in a certain way, then you would try again using TCP. And the reason for this is TCP takes a lot longer to set up and tear down the connection. What you want to do is get your question out and get your answer back as quick as you can, so it's done with a single exchange of packets. But the answerer is able to say that the answer I want to send you is bigger than will fit in UDP. And therefore, I'm giving you an empty answer, and I'm setting the truncation bit. I'm telling you that you're going to have to try again with TCP, which allows for me to send you a longer answer that will be long enough to send the one that you need. So this gives the attacker, or really the initiator, anybody, the people outside your network, outside your firewall, the ability to control your behavior. And anytime you see that, you probably want to treat it as a red flag and really study it carefully. Because what's happening is I am able to tell somebody that they should hold more state. And if I tell them that often enough, they will not have enough state to do the other things they also want to do. So it is a denial of service attack, but it's not done with tons and tons of packets. It looks very small on the wire, but it still creates a denial of service condition. You really should not have a protocol that allows other people to put you in that condition, but we have them. We have not just this one, but a lot of them. But this TCP retry after truncation is a big deal for DNS. And this is what it looks like. Question comes in, so QR equals 0 means it's a question, QR equal 1 means it's a response. So a question came in, the answer was too big, so we sent you back something that said truncated. And then you come back and say, okay, here I am on TCP, here's my question, and there goes the response. Now, that doesn't look so bad, but it's also not true, because what I'm telling you here is DNS messages. These are not packets on the wire. These are the packets on the wire, which is those top 2 are the ones you saw from the previous one, and then the next 8 are TCP setting up and tearing down connection state. So you're not only causing other people to hold state, you're causing them to send and receive more traffic. And if you wanted this to turn from a non-congestion, non-volumetric attack into a volumetric attack, all you have to do is turn the knob and do more of it. And that's a little bit scary. Now, there's something you can do. A lot of attackers do this. It's a slow loris attack, where after you've got the other guy holding some state, you simply deny him the response he's waiting for and let him eventually time it out. And he'll reach an error condition, close the connection without permission, and that'll get syslogged on both sides, which becomes another element of the attack. So this is like a kick me sign. This is a protocol that has put a kick me sign on your back. But in fact, this is still not what's happening, because there's also going to be a web server inside that firewall. And so if you didn't turn this into a volumetric attack, but you did cause that stateful firewall to remember all of the open TCP flows that you were causing people to do by how you answered their DNS questions, you can fill up the firewall state table so that it has no room to store the state about web. Now, there's an argument to be had about where that web server belongs in the topology, but pretty much every time this has been reported anywhere, a flurry of responses comes back that says, you don't want to do that, you want to do this, which is to put the DNS server outside the stateful firewall. Because the DNS server has a slightly better chance of being able to manage high levels of state by discarding it opportunistically than that firewall has. The firewall wants to do the best job it can for you, and it does not know what is going on inside the DNS protocol the way that the DNS server does. So you can argue about whether the web server ought to be back there behind the firewall, but you can't argue that having a DNS server behind that firewall is not just a kick me sign, but actually walking up to strangers and asking for trouble. I originally put this presentation together because a large national bank in one of the top 10 economies in the world got taken off net to the point where they were not able to answer user commerce web traffic, and this slide presentation was made for them, which is, doctor, it hurts when I do this. Well, I mean, stop doing that. So anyway, once you get your DNS server out, as I mentioned, you have the opportunity to put some protocol-specific logic into how you're going to manage your state. And when I say manage, I mean discard the stuff that is least useful or least likely to cause harmful side effects. And so we had to build this. And I'll show you in a moment the impact of having built it, which will tell you why we had to build it. But first, let me give you the theoretical background here. So if you're running one of these name servers, and again, in this case, it's a content server. It is answering questions for example.com or wherever it is that you work. That server has to be extremely well provisioned, over provisioned, I might say. You might want that to be able to ask and answer 1,000 times as many questions as it will ever do in any healthy scenario, because when it's your turn, and the roulette wheel is always spinning, so when it is your turn to be on the receiving end of a DDoS attack, you want to be able to answer legitimate traffic at the same time that you're answering all of the non-legitimate traffic. And so it is crazy to build a name server that can only accept as many packets as are normal and healthy. You have to overbuild these. That's one of the reasons that so many people outsource their DNS, is they can't afford to over-provision this. Their whole business might only need 50 to 100 megabits of connectivity, but their DNS server needs 5 to 10 gigabits of connectivity just because it will get DDoSed. Okay, so once you've solved the problem by over-provisioning the server, then you've created a different problem, which again indicates that the bad guys have the option of forcing you through a flowchart. Do you want to die here, or do you want to go over there? Well, let's go over there. Oh, do you want to die here, or do you want to go further? So, because of packet source spoofing, which I shall explain in a moment, I can send a packet to all of you claiming to be from that guy, and you will answer him. And he will be suddenly in the position of having heard a lot of answers to a question he didn't ask. And if I do this 1,000 times a second, and there are millions of you, then he's probably off the network. And he could call you. Let's say one of you is running an important server, like the top-level domain server for .com, and this is participating in this reflected, spoofed attack. And he calls you and says, would you please stop DDoSing me? All you can really ask him is say, well, all I'm doing is answering the questions that appear to come from you. Would you rather I don't answer the questions that appear to come from you? And then he's got to answer the question, do I want to be unable to reach any .com name? How do I feel about that? So you did this by over-provisioning your name server enough that you would be able to withstand a DDoS. You made yourself into a perfect DDoS amplifier, reflecting DDoS amplifier. Congratulations, welcome to the next level. So we built some technology called response rate limiting. We means I was back at my nonprofit before I came to Farsight, so this was 2011, that simply kept track of how many repeated questions it had gotten, where the definition of repeated is kind of fuzzy, because it has to be a nearby question and it has to come from a nearby location. But the idea is to be able to, preferentially answer the queries that don't look like they're part of an attack. And we were able to do this because we have fairly deep knowledge of the DNS protocol. We know what state everybody's got to be holding, and we know in many cases we can see that a non-attack person would not have repeated this query. We have answered that question for him too recently and too often. So we had obviously some state management problems. You do not want to change from having unmanageable state over here that makes you offline to having it over there instead, which what we did is we said, what is the worst case? How much state could we be made to hold? And how can we design around that assumption? And really, probably when BSD Unix was first being built, having 2 megabytes on a machine was $1 million problem. And so the idea that we would burn 10 megabytes of hash table just for this problem strikes me as a little nuts. On the other hand, 10 megabytes costs a nickel. So yeah, we have a fairly large state table, but it's not infinitely growing. So we make sure that we will not become a source of a new state mass attack. And all of your authority servers need this. And if you're running Bind, if you're running NSD from InnoNet Labs, if you're running Kanat from BSidesNYC Labs in Prague, then this is part of your server. And PowerDNS has this now. It's in their DNS dist front-end utility. It works a little different. It's not the way we documented it, but it's better than nothing. Every server needs this, and we have documented it. We have made sure it's unencumbered. There's no patent. Nobody owes any royalties when they deploy it. It ought to be the default. And now that it's been out for 5 years, I am now making the rounds trying to get all of these name server implementers to turn it on by default so that even if the config file fails to mention it, this feature will be in place. So, some background. OPN is other people's networks. These are the ones that cause most of your problems, and they are, in fact, the least safe elements of your lived experience on the internet because you cannot pay money to get them upgraded or get their code updated. You can't expand their capacity. You can't re-educate their administrators. You are stuck with other people's networks as just part of the equation. When we talk about costs and benefits, other people's networks are far more cost than they are benefit. I mean, yes, I'm glad other people have networks or I couldn't talk to their customers, but that's about the only reason I'm glad that they do it. Source address validation, SAV, is the thing nobody does, which is the real fundamental enabler of that spoofed source attack, right? Because I mentioned, if I send a packet to all of you claiming to be from him, you're going to answer him. But my ISP ought to know that I'm not him. So when my packet is trying to leave my ISP's network, they ought to say, that is not the source address we gave you. Why are you trying to send a packet that did not come from you? And it should just drop that. And that's what you're seeing here. The attacker on the top is using the target's address as its source address on packets that go through that internet cloud that's on most sleds now. And it hits the reflector, and the reflector has no reason to disbelieve the source address, and it sends that red dashed line out to the target. And if this was only one packet or only one reflector or only one attacker, then we would not be talking about this, but it's always a lot of packets. And as I speak to you, there are at least 1,000 of these going on the internet. I see everything now. I have a global network of DNS, passive DNS sensors, and so I can tell you this is done all the time. Now the reason they do it is because that target tends to be an online gambling casino. And that casino is able to measure in the tens of thousands of dollars per minute of profit they don't make while they are offline. And so if you can send them a big DDoS for, say, 20 minutes, and then send them some email with your Bitcoin address and say, I need this many Bitcoins, or I'm going to turn that on at the top of the hour and leave it on all day, pretty much you can count on those Bitcoins flowing. And this is something that I can't seem to stop. And the reason I can't is, again, this attacker should have an ISP who stops them from using an IP address for their source that was not allocated to them. They don't. And it's not that they can't. All modern routing equipment has this ability. They don't want to turn it on because there will ultimately be some multi-homed customer who will complain, and they don't want to do any work to find out who that customer is. They also have the problem of the break fix flowchart, right? If somebody calls in and says, hey, my internet's not working, you have this list of places you have to check to see what it is that could be causing this problem. They are your customer, you got to get them back up. If you turn on this feature, that is one more thing that could be the cause of that problem. And you don't want to answer the phone anyway, but when you answer it, you sure don't want to have a long list of things to look at. So it's simple economics that keeps the source ISPs from turning on the feature that would save the rest of us. Now, I do want to recount kind of a fictionalized account of a real conversation that I had, which is I want to turn this on, and that means we have to delay something, the deadline for something else. The milestone is going to move out a couple of weeks, and we need to invest in some training, documentation. Okay, so how does this make us money? You want to make an investment? I'm your CFO. Explain it to me. Now, if I'm the CEO, I can tell him to shut up and go away, but I was not always the CEO. So I can remember having a conversation where I said, well, it actually doesn't make us any money. Oh, okay, well, then how does it save us money, right? That's the other reason you might make an investment. Well, actually, it won't save us any money. Well, then why do you want to do this? Who will it help? Oh, it'll help our competitors. Oh, Mr. Vixie, get the hell out of my office, is more or less what I remember hearing. So the internet is not good at aligning the interests of third parties. In fact, it is very good at misaligning those interests and having the practice still be practical. So we put out a patch to implement this response rate limiting, and that was itself a bit of a political headache because I hadn't really checked very closely with my colleagues about it. But again, I was the CEO, I was getting away with stuff like that. Immediately, my friends over at Affilius, who run the .info top-level domain, put it in production. And that conversation was interesting. They said, Paul, I've heard there's a patch. Well, yes, there is a patch. Well, we need the patch. Well, no, you don't need the patch because, you know, I was selling them Bind support service at the time, and I reminded them, whenever we send you new code for Bind, you put it into a test lab and you beat on it for 6 months, and then if it survives, then you put it in production. So yes, we have a patch, it'll be out in a few weeks and you can start your process. They said, no, Paul, you don't understand. I need the patch now. And you know, if somebody is in the habit of writing you checks and they make, you know, demands, then you might have to just say, well, here's the patch, but good luck with it. So the patch was running in production within 15 minutes of that phone call. And this is the result. So here's how you read this chart. The Y negative is request volume, and the Y positive is response volume. And the X is, of course, time, marching forward to the right. And what you can see is that their request volume was between 100 and maybe 300 megabits a second. And their response volume was anywhere from 1 to 2 gigabits per second, and that's simply because responses are bigger than requests. Thursday afternoon, they put our patch in, and as you can see, the request volume continued, but the response volume went down to something very, very small. And I later got the backstory over beer. By the way, I've not been able to pay for my own beer whenever Affilius is in the room ever since, so I guess there are some beneficial side effects to open source. And they told me that they were getting a lot of calls from people saying exactly what I told you earlier, please stop DDoSing us. And they kept answering, do you want us to just blacklist you so that we no longer answer any question from you about .info? Now, some people think .info is crap and said yes, but most people were afraid to do that. And I guess the ones who said yes probably were worrying for a different set of reasons. Anyway, the big concern that they should have had, and they would have had if not for the fact that their house was on fire, is what if we put in this patch and we stop answering legitimate traffic? In other words, what if we increase the latency, increase the number of retries? You know, there are some bad things that could happen to this thing that we're the sort of the public steward of this public resource of .info. What if there's a false positive? What if the code has a bug? They didn't have time to really investigate that question. But what I will say is that the grand total of complaints from people after Thursday afternoon who said, hey, you're not as reliable. I can't, I run the dig command and you don't answer or whatever. I'm seeing retries. The grand total of complaints that they've received, 0. So we got it right the first time. And that's why you need to be running this in all of your servers. However, that's not the end of the story. How much time have I got? Oh, good. All right. Because this is just DNS. And the reason we were able to write code that was able to be used in production without much testing and didn't cause any problems is not because we are especially great coders. Like, take a look at cron from the 1980s. It's because we knew the protocol really, really well. And we knew exactly what a good query had to look like and what a bad one probably looked like. And we did our own testing, did a bunch of self-red teaming to make sure that we weren't creating something that was trivial to bypass. But not everybody knows the DNS protocol well enough to think that through. The DNS is not, by a long shot, the only protocol that needs this attention. Every single protocol needs every single speaker of that protocol to be considered in this type of light. And then we need to add all of this new state and new complexity to every endpoint, because OPNs don't have SAV and aren't ever going to have SAV. So, to give you a couple of examples of what I mean by protocol aware, this is something a lot of people think they can do rate limiting in their firewalls. In particular, I, with my IPFW firewall, have got various kinds of rate limiting, but it's very coarse-grained. What you can do is essentially you're simulating a T1 at whatever speed you want it to run at with a certain queue size, and anything beyond that gets random early drop. It's just normal congestion control as if it was a router, but it's actually in a socket. And that's not good enough for this, because there will be too many packets that will match that will be both good and bad. So you have to look deeper into it than just what are the 5 tuples and how can I maintain a quota on each flow. Also, if you did what I just said and kept one for each flow, then you would be subject to a state mass attack, which would just move the problem from the first one you didn't know how to solve to be some other problem you don't know how to solve. So you can't do it in your router. And there are some companies in the DNS space who sell DNS appliances, which are really Linux 2U boxes with special plastic on the front of them. But there's a couple of them now that have got an interface card that does the rate limiting for them, so that this does not take precious CPU cycles from your main processor. And I quietly went into a customer of one of those smart firewalls or smart DNS appliances that had this wonderful hardware stuff, and I quietly wrote a program that would send the packets that would bypass that thing because it wasn't looking deep enough into the packet. In particular, if you see a negative answer, you need to know why that negative answer was generated. And that's something you won't be able to detect on the wire. This is not a bump in the wire answer. There is no bump in the wire answer for this, or we'd do it in our firewalls. This is something every protocol speaker has to do by uniquely being able to determine which things should not have been repeated. Now you can game anything, including us. I know how to bypass our stuff. And a couple of other people have figured it out also. It's not that tough. And so what you're really doing here is not making yourself perfectly safe, but rather making yourself less attractive. There's an old joke about 2 hikers in the woods who encounter a bear, and one of them reaches down to lace up his shoes. And the other guy says, "There's no way we can outrun this bear." And he said, "I've just got to outrun you." And so it's kind of a horrible joke, except I have friends like that. And yet it's also the case that if we harden the heck out of every name server, if we make it the default, if everybody within the sound of my voice and all of your friends as well turns this on, then there will be fewer name servers available to bounce this type of attack off of. And that means that the ones who are left will get used more often. Hopefully, they will get used often enough that it will start hurting not just their victims, but themselves. And they will, I can tell you that Affilius, when they were sending 2 gigabits of response traffic, they had to pay for that, right? That changes how much IP connectivity you have to buy. So if we can get a smaller number of people to amplify more attacks, then we can eventually make it their problem to figure out why their internet connection costs too much, and then maybe they will also turn this on. I wish I knew a better answer. This sounds quite Darwinian to me, but it's what we do, because it's the thing, everything else we tried didn't work. So ultimately, it's a token credit scheme, which is as old as the hills when it comes to quota management. And you just have to be able to remember which start of authority record they were in at the time the response was generated. So that's basically which zone they are in. And you have to know which client network it is, but we don't know the size of the remote network, so we're making gross generalizations and assuming /24s for IP version 4 and /48s for IP version 6. And we allow you to override that in the config file, but so far nobody has yet overridden it and said, hey, this works better. Generally, the defaults we chose are the ones you should choose. So just mention this briefly in your config file and the rest of the logic will just kick in. And dare I mention, it won't cost you any CPU time, it'll save you network bandwidth, and it'll save you the psychic pain of having caused other people to receive traffic from you. Right. So, last but not least, I want to say that there is a protocol that we think of as not being susceptible to this that is, and that's TCP. So the reason we don't think of TCP as being susceptible to a spoofed source DDoS attack is because of all that setup and teardown traffic, right? Somebody sends a SYN, you send a SYN ACK, they send the ACK, and by that time you're fairly sure that you each know the other person's random initial sequence number, and that they really have to, there has to be somebody at that address who is, who knows they're talking to you. In other words, not spoofed. And it is absolutely the case that at an application level, after the TCP session is set up, that is true. However, that initial SYN has a problem. There's a bug in the TCP specification. Because a SYN, the SYN, has a sequence number. It, just like one character of data would have a sequence number, so it is that the SYN has a sequence number. And the specification for TCP says that if you transmit something that has a sequence number, like the SYN ACK in this case, and you don't get an acknowledgement, then you have to retransmit it. Now, this is the one part of the TCP state machine that didn't need this, because frankly, if you only sent one SYN ACK in response to a single SYN, right, you didn't have a retry timer on that SYN ACK, it's fine because no state will exist for anybody, and the original initiator, if they're a real person, will eventually send another SYN, to which you can send another SYN ACK. But that's not what the spec says. So what I've drawn here is the BSD case, which is where I can send one SYN packet to each of you using his source address, and you will each send him, if you're BSD systems, 5 SYN ACKs. And that's a pretty decent amplification factor. People don't think of it as an amplification problem because the SYN ACKs you send him are not going to be back-to-back. We normally think of DDoS as when your link is full. And yet, if there was 1 million of you, instead of just this classroom, you would each be sending enough packets with your 30-second retries or 5-second or 1 second, whatever your retry was, you would be sending enough traffic to congest that guy's link. That means that to fix this, every TCP responder, in other words, every web server in every home appliance or IoT device, everything on the internet that is able to receive not just TCP/80, but TCP on any port number has to have rate limiting. They have to remember what's been done recently, or they have to violate the spec. I've been trying to get the IETF to change the spec, but the TCP specification is carved in granite, and they do not want to admit that this was a bug in it, and so I don't think we're going to see a spec update. I did not discover this. I've given the authors of a WOOT paper that was in 2014. I kind of knew generally that this was a problem, but they went and experimentally proved it and also found about 8 other variations that show that the problem is even worse than I am describing. Now, I do want to say that Linux behaves differently. Instead of 5 packets, it will be 50. So I think sometimes about the long tail problem that we have where, I put maybe some bug or didn't understand what I was doing in get host by name in the original C library for DNS lookups. And then someday we fixed it, but there was so much of it that had been written into ROMs of small, cheap devices that they weren't going to get patched. And we see that more and more, and we're going to see more of that on the IoT front, right? These IoT devices cost an awful lot less than the ones that they don't have ROMs. They're the whole thing, the whole IoT controller in the bottom of that light bulb sold for a nickel. So they don't really have time in their schedule or money in their budget for red teaming it to see if it has a problem. And their resources are so constrained because they have so many competitors that really, if you game this out, you'll decide, well, probably it can't be patched, and that's a problem. Or it might be patchable, and that's a problem, because you never know who's going to be sending those patches. And so there's not a real good outcome there. On the other hand, we have determined that UV radiation is the great killer of electronics and the plastic cases that they are in. And at least with refrigerators and toasters and other home appliances, they tend to get replaced every couple of decades. So there is a chance, we're adding 6 million IoT devices to the internet every day. And there is a chance that within 20 years or so, the ones we're adding now that have this bug will start to die, and that sometime between now and then we will stop adding new things that have these bugs. So I think we'll probably all be fine. So I'm often criticized for coming into a room like this one and telling a story like that one and then not having some call to action. Okay, Paul, you've described the problem. What should we do? Well, change human nature. I don't really know what to do. I mean, we fixed this for DNS because I know how to do that. I don't know how to get TCP fixed, and I don't know how to get NTP fixed, or NFS, or SMB, or any of the other things that use UDP. I definitely know that people are not going to turn on source address validation. So brainstorm. Maybe you've got an idea. I know I'm fresh out. Yes, so the idea of using liability law as a way to get people to clean up their acts is probably, well, it's better than nothing, but it's not as simple as that, because these online casinos are often in offshore haven countries, so that they won't be subject to national law. They may not have a national police force or even national courts. And if they did, then they're subject to various kinds of treaties to try and figure out how you, as a California ISP or whatever, would end up owing them some settlement after some lawsuit. It's a very complicated arrangement. It's also very difficult to find out which ISP that was, right? So again, we use the case where I send you guys a packet, and I claim to be him, and you all answer him, and he's wondering, who are your ISPs? Well, he won't be able to find that out very easily. And certainly if there's 1 million of you, there's probably 1,000 of those ISPs. So by making sure that this is death by 1,000 stings, we have made it almost impossible for any success that you have in getting recourse to have any impact on their resources going forward. I'll come back to you in a moment. Over here.
For the SID use case for flood attacks, can that at least partially be mitigated by enabling SID cookies on
Yes, there is something called SYN cookies that Dan Bernstein successfully got into the TCP state machine about 20 years ago. But right now, the logic that uses them is congestion-based. In other words, it goes into SYN cookie mode when it has seen too many per unit time. This isn't going to see very many per unit time. So what I'm happy to say is that there is now a kernel option that you can use the SYS CTL command on FreeBSD at least, to say, please violate the specification in this way. Send only one retry, or send only one response. Eventually, I'm hoping to get those people to make that the default, but FreeBSD is a very small part of the universe at the moment.
Do you know the SCTP protocol is vulnerable to such amplification attacks?
SCTP is one of the protocols I was thinking of, although I can never remember where all the T's and P's go, but SCTP is like TCP, but much better. TCP only has a 32-bit CRC, which means that the probability of receiving data different than what was transmitted approaches unity at 4 gigabytes. So if you're transferring large files and having problems, it's because of cosmic rays. SCTP uses 48-bit CRCs and is not vulnerable to any attack of nature or man. And it does not have this problem because it has cookies all the time. We would so quickly have used SCTP for DNS. We would have moved off of this UDP horrible thing and the TCP and the fallback, and we would use SCTP. But since no middle box allows packets that it did not understand when it was made 25 years ago, and SCTP wasn't here then, SCTP is hitting a black hole. It is really only used for voice over IP, that was how it got funded. And all of the people who are doing voice over IP with SCTP are ready to fall back to UDP when the other end can't hear them.
Not long ago, the industry were talking about an increased volume of attack on DNS poisoning and all that, and then some regulator authority researchers came out and say, let's all put DNSSEC on. And then later, researchers came out and say, oh, wait a minute, when we put DNSSEC on, we're going to have massive flood of DDoS due to similar pattern that you're talking about. I thought, could you please share your thoughts on this? Which one's better? Do we want DNSSEC or do we want something else?
So DNSSEC is a bitter pill. It creates almost as many problems as it solves, but it is a net good, no matter how much it hurts. And so I have deployed it. I recommend that you do the same. DNSSEC is a story as old as mankind. It took 16 years. We restarted 4 times from scratch because people kept coming in late in the game and saying, wait, but it doesn't also do this other thing that I also need. And we've come up with something that doesn't have a backward compatibility mode. There is a new record type in the system called DS for delegated signer, which exists in the parent in the same node as the delegating NS records. And that means you have to have an exception. If you're a validating resolver, you have to know that if the thing you need is a DS record, you don't send it to the closest and closing name servers. You send it one hop up from them because that's where the DS record is. And of course, a lot of middle box DNS forwarders don't know that rule, so you can't deploy end-to-end DNSSEC behind any middle box that was made more than, say, 3 years ago. So I can't say it's an unmitigated disaster because it is slightly better than it is worse. But ultimately, this exposes the flaw in human engineering. People solve the problems they have. They don't think about the problems other people are then going to have. That's when you ask them about that, they will generally imitate a Tea Party member and say, oh, let's just let the market sort that out. And, well, so the market is DDoSing that guy because I'm sending you packets pretending to be from him. And the market thinks that's just fine because for each one of you, no pebble feels itself to be part of an avalanche.
Well, let us know which maybe we can come up with
We're out of time. Thank you all for coming.
Thank you.
Great job, sir.
Thanks.
As always.
It was fun.
Pleasure to meet you. Yeah, they don't want to let you go.